Bismillahirrahmanirrahim. This is my first video to be uploaded on US YouTube as assigned by my departmental teacher Zubair Ahmad, who is our departmental head in USP Cast department in Mehran University, Jamshoro Sindh. And USP Cast is earlier it was a funded by US aid, and now it is on its own by funded genuinely and by our university, Mehran University of Engineering and Technology, Jamshoro Sindh. So as I were assigned to discuss absorption processes depending on the some research papers. So these two research papers have been assigned to me. One is conventional and non-conventional adsorbents for wastewater treatment, which is authorized by Gregorio Crini, and other is heavy metal removal from wastewater using low-cost absorbents, which is written by Ashutosh Tripathi et al. And it is presented by me, Sikandar Lodi, and the contents that I am going to discuss here is a background about the absorptions, their introduction, wastewater treatment by absorption processes, types and absorbent classifications, mechanisms of adsorption and pollutant removal, and then why do we need absorbents, then conclusions and references. So background contaminants removal from wastewater is a major challenge in the field of water pollution. Among numerous techniques available for contaminant removal, adsorption using solid materials named absorbents is a simple, useful, and effective process. The absorbent matter can be mineral, organic, or biological. Or we can simply say that the biological and physical and chemical type of materials. Activated carbon is preferred. We know the activated carbon is most conventional material that has been used on the large scale, including industrial scale. Activated carbon is extensively used not only for removing pollutants from wastewater streams but also for absorbing contaminants from drinking water sources, e.g., groundwaters, rivers, lakes, and reservoirs. However, the widespread use of activated carbon is restricted due to the high cost. And then in the last 3 decades, numerous approaches using non-conventional adsorbents have been studied for the development of cheaper and more effective adsorbents to eliminate pollutants at trace levels. This review gives an overview of liquid-solid absorption processing using conventional and non-conventional adsorbents for pollutant removal. So in these past years, the Pakistan have face some same issues with the quality of waters, and therefore they have assigned and built an department in Sindh, Jamshoro, which is I'm a student of. So they have contributing a lot to improve the water quality by using different techniques. So in introduction, particulate metals began to affect the environment during the Industrial Revolution. Although some metal ions are disseminated into the environment naturally by both geological and biological activity, human activity today produces a greater input. Today we are in the pollutant removal age, and it is therefore not surprising that there has been considerable effort to develop technologies to reduce contaminant emissions. Industrial sector consumes significant volumes of water. Those in industrial areas like textile industries and consequently generates considerable amount of wastewater discharge containing both mineral and organic contamination. Wastewater treatment is becoming ever more critical due to diminishing water resources, increasing wastewater disposable costs, and stricter discharge regulations that have lowered permissible contaminant levels in waste stream. The diversity of water pollutants calls for a wide range of treatment methods that are not only effective but also technologically and economically feasible. Removal of contaminants from industrial effluents include biodegradation, precipitation, chemical oxidation, solvent extraction, evaporation, electrochemical approaches, and so many others like cementation, membrane filtration, phyto phytoremediation, ion exchange, and carbon absorption. And uh, in general terms, activated carbon must be thought of as being most effective absorbents, and as such, their performance is removing contaminants such as metals, radionuclides, rare earth elements, dyes, phenolic and aromatic derivatives, pesticides, pharmaceuticals, and drug has been examined widely. However, despite the excellence of their performance, these systems are expensive to use and as such cannot be thought of as truly viable option in many parts of the world. Attention has turned to absorptive properties of other non-conventional solid materials proposed as low-cost, efficient, and green absorbents for pollution removals. So these papers outline some sort of principles of contamination absorption onto solid materials. The review also proposes a classification for different types of materials used and discuss different mechanisms involved in the absorption phenomena. So wastewater treatment by absorptions. There it is a relationship between the three components of an absorption system, like absorbent, and wastewater. They have the similar chemistry, their affinity, and their behavior. Absorption is a process of separation during which the substances of a fluid, liquid, or gas bind to the exterior and interior surfaces of a solid material called the absorbent. The separation is based on the selective absorptions like thermodynamic and kinetic selectivity of the contaminants by an absorbent owing to specific interactions between the surface of the absorbent material and the absorbed contaminants. Simple mass transfer from the liquid phase toward the solid phase. This surface phenomena is a manifestation of a complicated interactions among the three components involved: the adsorbent, the adsorbate, and the wastewater, effluent, synthetic solution, or what. However, the affinities between the adsorbate and the solution, the adsorbent and the solution, the contaminant molecules can also play a major role in adsorption. In aqueous solution, hydrophobic compounds have low solubility and tend to be pushed to the adsorbent surface. Now their classifications, types of absorbent and class. Like first, there are two types of absorption types, like physical absorbents and chemical absorbents. Physical absorbents are those is a process in which binding of adsorbent on the adsorbent surface is caused by van der Waals forces. Van der Waals forces are some of the forces that have the tendency to attract or repel those electronic structures. And van der Waals forces originates from the interactions between induced permanent and transient electric dipoles. Physical adsorption can only be observed in the environment of low temperature and under appropriate conditions. Now the chemical absorbents. It is a kind of absorption which involves a chemical reaction between the adsorbent and the adsorbate. The strong interaction between the absorbent and the substrate surface creates new types of electronic bond, covalent or ionic. Chemical absorption is also referred as activated absorption. The adsorbate can form a monolayer. It is utilized in catalytic operations. In general, the main steps involved in absorption of pollutants on solid adsorbents are these: transport of the pollutant from bulk solution to external surface of the absorbent, internal mass transfer by pore diffusion from outer surface of adsorbent to the inner surface of porous structure, adsorption of adsorbate on the active sites of the pores of adsorbent. Now their classification. They have been classified into the five categories: natural materials such as sawdust, wood, fuller's earth, or bauxite. Secondly, natural materials treated to develop their structures and properties such as activated carbons, activated alumina, and silica gel that have been further discussed in the next slide. Manufactured materials such as polymeric resins, zeolites, or aluminosilicates. Agricultural solid waste also, and industrial byproducts such as date pits, fly ash, or red mud. And the last, biosorbents such as chitosan, or you can say chitosan, fungi, or bacterial biomass. Another simplified classification can be used as conventional and non-conventional mentioned below. You can clearly see the comparison between the conventional and non-conventional. Conventional absorbents have the commercial, inorganic, and ion exchange type of materials. The commercial has activated carbons like wood, peat, coconut shells, coals. Inorganic materials include activated alumina, silica gel, zeolites, molecular sieve. And ion exchange resins are polymeric organic resins, non-porous resins, porous cross-linked polymers. And non-conventional adsorbents at subcategories like depending on the natural materials, agriculture waste, and industrial byproducts. They have the same categories like activated carbons, biosorbents, and miscellaneous absorbents. So they have been listed like agriculture solid waste in containing fruit stones, biogas, coir pit, date pits, maize cob, industrial byproducts, PET bottles, waste tire, sewage sludge waste, and these other mentioned in here in detail. So mechanism of absorption, how the absorption processes work. I have tried to merge it in the most simple manner. So in the context of absorption, the major challenge is to select the most promising types of absorbent, mainly in terms of low cost, high capacity, often expressed by the value, high absorption rate, high selectivity, and rapid kinetics. And other point is absorption mechanism involved in contaminant uptake can orientate the design of desorption strategy. For example, the recovery of certain contaminants such as precious metal ions are also an important parameter for the economics of the process. These mechanisms are not fully understood because many interactions are possible. Here is the table which justify their advantages, their the materials that plays the role, and their limitations, their advantages and their features and their mechanisms. Like activated carbon have the mechanism like the most effective absorbent in industry. Charcoal is the oldest material known as known in wastewater, and their limitation is initial cost of the carbon. All we have to do is to invest initially, so get the maximum output. And the other form is powdered activated carbon like granular activated carbon and other forms. And then activated carbon from solid waste like agriculture waste, wood waste, city waste, air, industrial byproducts, and sand. They have, these are their characteristics, their advantages, features and mechanisms, and their limitations. Now the pollution removal, how to we can remove the pollutant. The researchers there in their research papers have suggested or the classification of contaminant adsorption mechanisms. They described the four possible mechanisms have been proposed, namely physioptions, chemisorptions, ion exchange, and precipitation. In physioptions, we can do follow these processes to remove the pollutants like surface adsorption, van der Waals interactions, hydrogen bond, and Yoshida interaction. In chemisorptions, electrostatic interactions, complexation, chelation, inclusion, complex formation, ion exchange, reversible exchange of ions. And in precipitations, we know the mechanism of precipitations, the like micro precipitation, surface precipitation, and proton displacement. Now, the listing of the low cost absorbents in natural minerals, we can uh, use these absorbents to filter out the polluted water like zeolites, clay, peat moss, chitin. And in agriculture waste, rice husk, maize, leaf, black gram husk, waste tea, walnut shell, papaya wood, peanut hull, pellets, grape stalk waste. And finally, in from industrial waste, so we can obtain the fly ash as the absorbents, blast furnace sludge, waste slurry, red mud, coffee husk, areca waste, tea factory waste, sugar beet pulp, waste biogas, residual slurry. And now the question is, why do we need absorbents? By using this contaminated water with the clear impurities mixed into it, we can these impure or impurities are included in there, and especially the heavy metals like arsenic, cadmium, chromium, copper, nickel, zinc, lead, mercury. And these all leads to the severe hazardous diseases like skin manifestations, renal disorder, nausea, Wilson disease, chronic asthma, depression, lethargy, neurological signs, and increased thirst, and so many like the kidney problems and the respiratory as well as nervous system. Adsorbents are highly important in the enhancing the removal efficiency of pollutants from wastewater due to their high stability. Adsorption properties result in the manufacturing of high quality and economically feasible products for the various applications such as removal of metal which are highly hazardous for health. That's why we need the absorption process that I have stated earlier, that we by using these adsorbents, by converting them from raw form to in activated carbon form, we can use them in the cheaper and most lower cost, and in indulge or increase the capacity of water purification. Now the conclusion. These things, that these highlighted points that I have been observed from these above mentioned papers, like preserving the environment, the public demand for pollutant free waste discharge to receiving water has made decontaminations of industrial waste a top priority. And then this is a difficult and challenging task because it defines a universal method that could be used for the elimination of all contaminants from wastewaters. Among the numerous and various treatment processes currently cited for wastewater treatment, only a few are commonly used by the industrial sector. However, it is now accepted that adsorption is the procedure of choice and gives the best result, as it can be used to remove many different types of contaminants. Author proposed to explain adsorption mechanism. Commercial activated carbon is extensively used not only for absorbing contaminants from drinking water sources but also for removing pollutants from wastewater stream. Other conventional materials include organic resins, activated alumina, zeolites, and sand. Non-conventional absorbents can be also obtained and employed as low-cost and efficient solid dissolvents. Perhaps one reason why non-conventional absorbents have not been widely used in industry is the lack of knowledge about the engineering of such material. Researchers think for novel absorbents to be accepted by industry, it will be necessary to adopt a multidisciplinary approach in which chemists, engineers, material scientists, biologists, microbiologists, and computer scientists work together. The opportunity now exists to consider other solid materials such as biomass, cellulose, chitosan for emerging applications. They will undoubtedly be at the center of some extremely profitable commercial activities in the future, although their development requires further investigation in the direction of mechanisms, modeling of regeneration of the adsorbent materials if necessary, and of testing materials with real industrial effluents. Thanks.